How many proper subsets are there of the set consisting of A, B, C, D, E, F, and G? Now there's a formula for that, which I noticed in class that a lot of people had forgotten. And we talked about why this formula makes sense, but it's a little hard to understand, and there's no great shame in having forgotten it if you've seen it before. Simply, if we have the set, let's just say the set AB has how many subsets? It has 4 subsets. The empty set, the set consisting of A, the set consisting of B, and the set is, of course, a subset of itself, because the subset relationship says every element of the first set is an element of the second. Every element of a set is an element of itself. Now, that doesn't satisfy the definition of proper subset, and you should remember what that is, but we'll talk about that shortly. In any case, this is the number of subsets, and we're going to look at the number of subsets first. Now, if we wanted to list the subsets of A, B, C, we'll note that we could add C to any one of these sets and get a new set, or we could simply use any of these sets. Any of these sets is a subset of the set A, B, C, right? All these being subsets of the set A, B are subsets of the set consisting of A, B, C. But if we add C to each of these subsets, we get a new set that's a subset of A, B, C. So we can use the old subsets, that is the empty set, the set consisting of A, set consisting of B, and the set consisting of AB. And we can make new subsets. If we add C to the element, well, to the empty set, we get the set consisting of C. If we add C to the set consisting of A, we get this. If we add C to the set consisting of B, we get this, BC. And if we add C to the set consisting of AB, we get ABC. Well, it should be obvious then that by adding an element C to the set AB, we've doubled the number of subsets. We can count all the old subsets, or we can add C to each of the old subsets to get a new subset. And that doubling will continue. There are now 8 subsets of the set ABC. A 2-element subset, any 2-element subset is going to have 4 subsets. Any 2-element set is going to have 4 subsets, because any 2 elements you can do the same thing with that we did here. You'd have a 1-to-1 correspondence there between the subsets. In any 3-element subset, we're going to be able to take the subsets of the first 2, the set consisting of the first 2 elements, the 4 subsets that we get from the first 2, and add the new element to each of those to get new subsets, and then include the old subsets. So every time we add an element, we're going to double the number of sets. So we can make the statement that adding an element to a set doubles the number of subsets. Now we'd have to make that just a little more, we'd have to state that a little more carefully to have a statement that would really stand up, but that's the idea. So it follows from this idea and from the fact that a 1-element subset has 2 1-element set has 2 subsets by what we call mathematical induction, that the number of subsets of a set with n elements has 2 to the n subsets. N elements gives you 2 to the n subsets. Now let's go back and answer the question that was originally posed. Okay, this is a 7-element set. It has to have then 2 to the n, which equals 2 to the 7th. And if you multiply out 2 to the 7th, you find that that's 128 subsets. For smaller sets, you can list the subset. And you could actually list the subsets of this one if you're careful and systematic. It would take a few minutes, but you could list 128 subsets. It's not an inordinate number, but there's really no point. Once you see the pattern, you see how the number of subsets continues to double, and this becomes convincing.